This program will provide information on basic low-angle rope rescue operations. Used in conjunction with hands-on rope rescue training under the direction of a qualified instructor, this program will provide firefighters with a handy basic rope rescue resource. Low-angle rope rescue refers to an environment where the rescuers, their gear, and patient, if any, are primarily supported by their feet. The ropes they are connected to provide safety, assistance, and positioning. Studies have shown this definition includes slopes up to 55 degrees. High-angle rope rescue refers to an environment where the rescuers, their gear, and patient, if any, are primarily supported by their rope system. Regardless of whether a rope rescue system is low or high angle, all should be approached with the same level of stringency because all are potentially hazardous. A safe, repeatable, and systematic approach to rope rescue will ensure effective low-angle rope rescue operations. PPE for rope rescue consists of long pants and long sleeves, a tech rescue brush or structure helmet, boots, eye protection, and rigging or utility gloves. Rescuers going over the side shall always be in a full-body harness. Rigging can be performed with bare hands or rigging gloves. When lowering or raising operations begin, however, all personnel involved in the evolution shall be wearing gloves and all PPEs as shown. Loosen all harness straps fully and hold out to one side, making sure the harness is oriented correctly for donning. Next, step through the leg loops one leg at a time, then pull the waist strap up to waist level. Tighten the waist strap enough to hold up the harness. Next, pull the shoulder strap closest to you over your head and adjust snugly. Finally, adjust leg loops snugly and check all straps and buckles for proper adjustment and secure fastening. Rope rescue systems always employ a minimum of 2 ropes, a main line and a belay line. Each will always have their own separate and dedicated anchor. The most convenient anchors can often be established on vehicles. The outside rear dual on a fire apparatus will always be the coolest of any other wheel on the rig after a hard run. Use the outer dual for this reason when establishing an anchor on a wheel. Start with a 20-foot length of webbing and tie it in a loop with a water knot as shown here. Next, double the loop you have formed. Now, push a bight of the doubled webbing through one of the wheel cutouts, or handholds as they're also known, pulling the bight around the tire. Pad the wheel cutout if it has sharp edges to protect the webbing. Form a girth hitch with the webbing, then lock it by pulling this portion of the webbing through like this. This anchor is referred to as a double locking girth hitch. Tie 2 on one wheel as shown here. One anchor will be for the main line and one will be for the belay line. Any substantial anchor point capable of supporting at least 5,000 pounds will be adequate for rope rescue. Generally, large living trees, very large rocks, substantial structural components, and other immovable objects of obvious permanence will serve as good anchors. The anchors in the following sequence are permanent rated anchorages on a rope rescue training prop. Main lines are constructed utilizing an RPM. The term RPM refers to rack, pulley, and mariners. The rack is a friction device. The pulley provides mechanical advantage for raising systems and also includes one prusik loop. The mariners is a load-releasing device which also includes a pulley and prusik loop. All components are assembled with carabiners on an anchor plate and should always be laid out from left to right like one would read RPM, as shown here. Lock only the carabiners that will be in use on the RPM to prevent unnecessary locking and unlocking of carabiners. Prepare the main line by reeving it into the rack like this. The more bars the line is acting upon, the more friction that is provided. 4 or more bars should be employed for most low-angle rescue scenarios. Belay lines are constructed utilizing 2 unequal length prusik loops and a mariner's, as shown here. This is also known as a tandem prusik belay. Tie each of the prusik loops onto the belay line utilizing a prusik hitch. Make sure that the longer of the prusik loops is positioned on the load side and the shorter of the prusik loop is on the anchor side, as shown here. Dress both prusik hitches like this and snug up. The system shown here is referred to as an inline RPM system, as the main line is in line with the direction of the rescuer's travel. Start by grasping both the main line and belay lines and pull both lines simultaneously. Pull about 20 feet of both lines and grasp both with your left hand. With the litter head facing towards the anchors, kneel on the left side of the litter and wrap the top rail of the litter with both lines a minimum of 3 times at the litter head. Next, tie a double long-tail bowline like this. Then reeve the long tails down the litter frame, keeping the lines under the top rail. Next, tie a figure 8 on a bight in both long tails. Have 4 rescuers in full body harnesses each tie into the litter frame's top rail with a prusik loop and carabiner attached to the harness's lower front D-ring. 3 rescuers may be used in very steep terrain to reduce the weight on the system. Provide a secondary connection for each rescuer to the longtails attached to their top front D-ring, as shown here. The system is now ready for a lowering operation. An edge attendant must be designated and positioned near the rescuer's point of departure and in full view of all on-scene personnel. Provide fall restraint to prevent the edge attendant from traveling over an unprotected edge if a fall potential exists. A Class 2 pelvic-type harness is acceptable for fall restraint connected to a secure anchor with a lanyard. Adjustability can be provided on both ends of the lanyard with prusiks. All rope rescue operations and communications are controlled by the edge attendant. A mainline operator controls the main line. A belay line operator controls the belay line. 3 or more haul team personnel pull the main line in raising operations. A safety officer checks each rescuer and the overall system for safety prior to the evolution beginning and monitors the safety of the evolution throughout the operation. The safety officer may hold more than one job. A rescue group supervisor is in charge of the overall operation. The rescue group supervisor may hold more than one job. 3 or 4 rescuers go over the side to access patients in low-angle environments. In high-angle environments, 1 rescuer goes over the side to access patients. The minimum staffing for a low-angle rescue is 9. The minimum staffing for a high-angle rescue is 7. All rescuers and the rope rescue system are inspected by the safety officer prior to the beginning of operations. Unsafe conditions, if any, are corrected. Nearly all low-angle rope rescue operations start with a lowering operation. Use a minimum of 4 bars on the rack for adequate friction. Rescuers need to take a minimum of 3 20-foot lengths of webbing and medical gear with them in the litter. All commands and communications go through the edge attendant. This rope rescue system is configured as an inline RPM. The RPM is in line with the direction of rescuer travel. Once the patient is reached by the rescuers, the rope rescue system is converted to a raising system. This process is referred to as changeover. While this process is occurring, the rescuers attend to the patient. The rescuers may disconnect from the system to facilitate patient care if the terrain does not present a fall hazard. Once patient contact is made, assess them and provide appropriate medical stabilization measures in preparation for evacuation. Once the patient is medically stabilized, place 2 20-foot lengths of webbing in the litter as shown. Load the patient into the litter, providing for a C-spine stabilization if indicated. Place a helmet and eye protection on the patient prior to securing them in the litter. Lash the patient into the litter using the techniques and sequence shown. All lashes are secured utilizing a round turn with 2 half hitches. Once the patient is secured, assure that all rescuers are attached to the system with 2 points of contact as they were when lowered. The changeover procedure is initiated when the rescuers first reach the patient. First, the rack is locked off. Then the prusik on the mariners is tied on the main line. The pulley on the mariners is placed onto the main line as shown. The pulley and prusik on the anchor plate are removed and placed into service on the main line as shown. Finally, the rescuers are informed that changeover is about to take place, and the main line is slowly removed from the rack, transferring the load to the prusik on the mariners. The system is now ready for a raise. Position haul team of 3 or more personnel on the main line and begin slowly raising rescuers on the edge attendant's call.
Prepare to raise! Raise!
Haul team personnel peel off the system when out of room and return or caterpillar to front of team. When haul system becomes too short to continue hauling, the ratchet prusik on the top pulley is set and the system is extended or reset. Hauling is resumed and the sequence repeated until rescuers and patient have been fully raised up the slope. In addition to the inline RPM configuration that we have just reviewed, there are 2 additional configurations commonly used for rope rescue. One is referred to as a change of direction RPM. This configuration simply bends the main line 90 degrees to move the main line off of a roadway or to a more advantageous location. This is achieved by adding a change of direction pulley to the main line and locating the RPM at an anchor 90 degrees from the pulley's location. The belay line should be located near the point of departure. The RPM's configuration for a change of direction is the same as an inline RPM. More mainline rope length is required for the change of direction RPM than for an inline RPM. The final RPM configuration we will look at is the pig rig. A pig rig is used when the maximum length of the main line must be extended over the side to reach victims. To achieve this, the RPM and belay lines are anchored near the point of departure, allowing nearly all of the main line's length to be deployed over the side. Once the victim has been reached, the RPM is reconfigured and an additional rope is piggybacked onto the main line as shown, providing mechanical advantage for raising operations. The ratchet prusik cannot reliably self-tend in this configuration and therefore must be moved away from the pulley on the end of the mariners. This configuration requires the ratchet prusik to be manually tended by a person as shown here.